It's 2026, and, if you just read the headlines, you'd be forgiven for thinking that the entire world of AI is just one giant, creative, text-generating machine. Generative AI is absolutely everywhere, but that creates a pretty big puzzle, right? What happened to all that, well, boring AI that's been quietly running our businesses for years? The fraud detection, the supply chains, the stuff that actually makes the world go round. It feels like it just, poof, vanished from the conversation. And that really brings us to the core question of this whole explainer. Is generative AI the only game in town now? I mean, has all that classic predictive machine learning we've invested in for a decade just become obsolete? It's a question that's frankly born from a massive hype cycle. But the answer has some serious strategic implications for your business as you try to figure out what to do next. So, to really get to the bottom of this, we're going to take you on a journey. First, we'll look at the great divide between these two AI worlds. Then, we'll dive deep into the data they eat and the algorithms they use. After that, we'll get real about the hardware and the costs involved. We'll unpack the surprising truth about ROI. And finally, we'll lay out the hybrid strategy that the smartest companies are already using to win. All right, let's jump in. Section 1, the Great AI Divide. And look, this isn't just about different kinds of models. It's about two totally different ways of thinking. On one side, you've got the super meticulous number-crunching analyst. And on the other, you've got this creative, idea-generating collaborator. They're basically operating in parallel universes inside modern companies. And understanding that is really the first big step to getting some clarity. So let's put a name on it. We're calling this the 2026 ML dichotomy. On one hand, you have your classic ship it machine learning. That's your reliable analyst. On the other, you've got this hype generative ML. That's your creative collaborator.
Okay, hang on a second. Analyst versus collaborator? That sounds a little bit like marketing fluff. What does that actually mean for someone who's just trying to run their business?
That is a very fair question. So let's break it down right here. Look at the top row. Operational philosophy. Classic ML is deterministic. You put the same numbers in, you get the exact same answer out, every single time.
Kind of like a calculator.
Exactly, like a calculator. A fraud model always gives the same transaction the same score. But generative AI, it's stochastic.
Which means?
It means it's based on probability. You can ask it the same question twice and get two slightly different, but still correct, answers. It's generating something new. Now, look at how we interact with them. Classic ML is usually automated, running in the background. Generative AI is built for conversation, for natural language. And that flows right into their nature. Classic models are specialists, hyper-focused analysts. One model for predicting churn, a different one for forecasting demand. Generative models are general-purpose reasoners. You can ask one LLM to summarize a document, then write some code, then brainstorm marketing ideas, all in the same conversation. Okay, so for Section 2, we're going to pop the hood, because to really get our analyst and our collaborator, you have to understand what they eat for breakfast and, maybe more importantly, how their brains are actually wired. And it really all starts with the data. Classic ML is the undisputed champion of structured data. We're talking the neat rows and columns in your spreadsheets and databases, the hard, numerical facts of your business. Generative ML, on the other hand, it thrives on all the messy, unstructured data of human communication, all the text, images, and audio files you have.
But hold on a minute. Can't a super smart LLM just read a spreadsheet? I mean, it can read anything, right? So why is this distinction still so important in 2026?
It's so important because of suitability and, frankly, efficiency. Yeah, sure, an LLM can read a table, but a lot of the time, it's just the wrong tool for the job. Just look at this chart. For something like fraud detection, you need a model that is lightning fast, cheap to run, and totally deterministic. That is the home turf of a classic model like XGBoost. Using a giant LLM for that is like using a sledgehammer to crack a nut. It's slow, it's expensive, and honestly, it's not even as precise. Same goes for demand forecasting. Classic models are built from the ground up to handle complex math and seasonality. LLMs, as we know, can really struggle with precise mathematics.
But if you flip it?
You got it. For document summarization, a classic model is totally useless. It can't generate new text. That's where the LLM's incredible ability to synthesize language just blows everything else away. It's really about picking the right brain for the right job. And this fundamental difference in their thinking, it's rooted right in their core mathematics. For a model like XGBoost, the formula is all about iteratively adding new functions to correct the errors of the previous ones. For an LLM, it's about predicting the probability of the next word given... Whoa, stop right there. My eyes are glazing over. That's just a bunch of math on a slide. Give me an analogy. In plain English, what is actually happening here? Haha, you got it. Fair enough. Think of XGBoost like building a house with a team of absolute specialists. The first guy comes in and builds a rough frame.
The next specialist comes in and says, hey, that wall is off by a millimeter, and fixes it. Then another one comes and corrects that tiny error, and so on and so on. It's this process of obsessive iterative error correction that results in a super precise, stable structure. And that's why it's so explainable and trusted in places like banking and insurance. You can actually trace back the decisions.
Now, an LLM, it thinks completely differently. Its secret sauce, this thing called self-attention, is more like a brilliant editor, reading an entire paragraph all at once. It doesn't just go word by word, it instantly sees the relationships between all the words, how the first word connects to the last one, how a single word in the middle can change the entire meaning of a sentence. This ability to see the broad context is what unlocks its creativity and reasoning.
But that's also the black box problem people talk about, right? It's a lot harder to explain exactly how it came up with its answer.
Precisely. And this brings us right to Section 3, the silicon reality. Because these abstract differences in logic and math, well, they have very real, very physical consequences when it comes to the hardware you need to buy, how you operate these systems, and, of course, what it all costs. This right here is one of the biggest practical divides. Your classic models, they're mostly CPU-centric. They run just fine on the standard servers that most companies already have sitting in their data centers. A GPU can speed things up, but a lot of the time it's just optional. Generative AI, though, is completely and utterly GPU-dependent. Its core math requires the insane parallel processing power you only find in chips with thousands of cores, like NVIDIA's H100s. The CPU is really just there to direct traffic.
So let me just get this straight. What you're really saying is that generative AI is just fundamentally way more expensive to run. Period.
More expensive and, this is key, way more complex to operate. It isn't just the hardware bill. The entire operational discipline has literally split in two. We are talking about MLOps for classic models and LLOps for generative ones. And they are not the same thing. Just look at the monitoring row here. In MLOps, you're monitoring for things like data drift and statistical accuracy. These are concrete mathematical concepts.
And in LLOps, you're monitoring for prompt drift and hallucinations? It sounds like you need a psychologist, not a data scientist.
It's a totally different world. You're dealing with fuzzy linguistic problems that require entirely new tools and skill sets to manage effectively. And this whole operational and cost divide, it leads us directly into our fourth, and I'd say maybe most contentious section, the ROI paradox. This is where we look at how these two types of AI actually deliver business value, and why there's such a huge disconnect between the hype and the reality. And let's just start with a number that should honestly stop everyone in their tracks. According to a 2025 study from MIT, 95% of enterprise generative AI pilots deliver zero measurable return on investment. 95%? That's a catastrophic failure rate. It sounds like the technology just isn't ready for business.
See, but that's the crucial point. The study actually concludes that this is not a failure of the technology itself, but an execution failure. It's a strategic mistake. Companies get all excited and they try to use Gen AI to automate an entire complex human workflow from day one. The successful 5%? They do the exact opposite. They target high-volume, low-risk processes first. Things like drafting an initial customer service response or summarizing internal meeting notes.
And this table just illustrates that paradox perfectly. Look at the ROI for classic ML. In manufacturing, predictive maintenance can give you a 300 to 500% ROI. In finance, fraud detection is a direct mission-critical function. These are massive, easily measurable, hard-dollar gains. And the generative AI side? Well, the gains are definitely real, but they just look different. A 40% productivity increase for your software engineers is huge, but it's an efficiency gain, not a direct revenue line item on a P&L. So you can think of it like this. Classic ML saves you money directly. Generative AI makes your people faster and more effective. Both are incredibly valuable, but you measure them in completely different ways. So if one gives you that direct ROI and the other gives you productivity, the obvious next question is, do you really have to choose?
And I'm going to guess the answer is no.
Exactly. As we're going to see in Section 5, the smartest strategies in 2026 are all about building a hybrid future where that analyst and that collaborator actually work together. And this case study from Grupo Wendy is a perfect example of this. They had these high-speed quilting machines that were failing unexpectedly. So first, they brought in the analyst, a classic XGBoost model that crunched all the sensor data and could predict a fault with almost 97% accuracy. Now that's great, but it doesn't tell the engineers why the machine is about to fail. So then they added a generative reasoning layer, a Bayesian network.
Okay, hang on. What's a Bayesian network, in simple terms?
Just think of it as a model that's really, really good at reasoning about cause and effect. It basically builds a map of probabilities to explain the why behind the what. And the outcome? You get the best of both worlds. You get the high-performance detection from the analyst, combined with human understandable, actionable insights from the collaborator.
And this hybrid approach is actually part of a much bigger strategic shift that we're seeing in 2026, the private AI imperative. Businesses are getting really nervous about sending all of their sensitive, proprietary data to third-party APIs. So instead of relying on one giant proprietary model that lives in the cloud, they're bringing smaller, specialized, open-source models in-house, running them on their own hardware, and this gives them complete control over their data, their costs, and their intellectual property. It's a fundamental shift from renting intelligence to owning it. And all of this brings us to our final section, your 2026 AI strategy. We've taken this whole dichotomy apart piece by piece, and now it's time to put it all back together into a coherent, actionable plan for how to navigate this new multi-model world. Here it is, the 5-point plan. First, protect the core. Don't you dare throw out your classic models. Optimize them for the high-stakes jobs they do best. Second, target your generative pilots intelligently. Forget trying to boil the ocean. Focus on those high-volume, low-risk tasks to get some early wins. Third, build hybrid pipelines. Combine the analyst and the collaborator.
Prediction with explanation.
Exactly. Fourth, pursue data sovereignty. Start planning your transition to private, open-source models now. And finally, number 5, standardize your governance. You have to treat your AI operations with the same rigor and discipline that you treat all your other critical IT systems. The key takeaway is that these paradigms are not competing, they're complementary tools for different jobs. And that leaves us with one final, and I think pretty provocative question. As you successfully build out this hybrid capability, your business is effectively going to have a superhumanly fast analyst and an endlessly creative collaborator at its disposal. So the ultimate question for every leader is going to be, when they disagree, who gets to make the final decision?